Hello guys, Matt is back with another video, and today we are on problem 5. So I've been getting feedback from some of you guys, so thanks for that. Keep me engaged in the comment section like you're doing now. For all the new people, if you haven't already subscribed, please click on the subscription button below so you get notified whenever I release a new video. So we have 44 more days till this series is over, so let's do it, guys. I've already taken the time to copy the problem from Project Euler, commented out the problem over here, the problem definition. As usual, it reads 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all the numbers from 1 to 20? What this is saying is you can divide this number over here, 2520, by all of the numbers from 1 to 10. So let's just see if this is the case. I'm just going to write a for loop here just to see if this is actually true. So we start from 1, we want to get to 10. So I'll say less than 11. Let's see. So I'll just try console log 25. So this should give us 0 for everything. We shouldn't have a remainder for any of them here. So I'll just log I on the side as well. So there. So let me just run this. So looking at that, dividing it by 1, we get the remainder is 0. Dividing it by 2, all of them are 0. Dividing by all the numbers from 1 to 10, we get 0. So that is the case for this number. We have to do this. We have to find the smallest number that can be divided by numbers from 1 to 20. So let's write our function to find out if a number is divisible by numbers from 1 to 20. So I'll call that function is divisible. So our divisible function should take in a number and then check if that number is divisible by all numbers from 1 to 20. So what do we want to do? So we'll loop from 1 to 20, from 1, then I'll say less than 21, then I plus plus. So if our number, if I is divisible, if our number is divisible by I, so if our number is not divisible by I, actually, we want to stop because we already know that, okay, this number is not divisible by all the numbers between 1 and 20. So if this is the case, then we want to return false. But if we manage to get out of the loop, that means we did not hit this condition. That means that it divided all our numbers between 1 and 20, so we can actually return false out of the loop, right? So this number should do that. So if let's run this guy for 1 and see for 2 for this number that we have. Actually, let's run it for that guy. So I'm just going to close this guy at the bottom so you give ourselves some space. So I'll just console.log and we just try and run it for that guy. And then we give it that input and see if that guy is divisible by numbers from 1 to 20. So it says false. Now I'm going to try and do something here. So let's give our number, our is divisible function another parameter. I'll just call this max, which is also a number. And then that number, let's use that number here so that we can actually use this for any So we can actually use this for anything we choose. So now if we run this guy for 10, because they told us it works for numbers between 1 and 10, so this should actually give us true for this new function. So I'm going to run that again, and we got false. We got false. Oh, we got false because we're returning false on for both conditions. We need to return true over here. Let's try that again, and then we get true. So for 10 it works. So now what we're going to try to do is try and use this function to find a number that works for 1 and 20. So I'll create this function called find smallest multiple. Finding the smallest multiple, what do we need? We can start off with our number from 1. So we'll start off with, I'll just say n equals to 1. We are searching for our n to see if the n is divisible, right? So I'll start at 1. And what do we want to do? We want to say while our number is not divisible by numbers from 1 to 10, right? While it's not divisible by numbers from actually 1 to 20. So here we have n, comma, so you wanted to say 20, while it's not divisible by numbers from 1 to 20. So we want to add 1 to our n, and then as soon as we find our n, we want to return our n to us. So I'll return n over there. So let's see what we get. Let's see what we get for this guy. So I'll say find smallest multiple. I'll just run it. And then we get this as our answer. Let's go test this out and see if this is actually the right answer on Project Euler. So I'll just paste that answer over there, and then 62860, and then check if, and that is the correct answer. So, but let us go back to our solution and see if we can actually optimize it a little bit, because it is actually not optimal at this moment. So the reason it's not optimal at this moment is because we actually don't need to look at some numbers, but we are, right? So here we're starting from 1, but we can effectively start from 20, because we know that the number we're looking for should actually be divisible by 20. But also one other thing, this our is divisible function over here doesn't need to start from 1. It can start from 11. It can start from 11 because at the moment we know that. So if we can divide a number by numbers from 11 to 20, that means we can also divide by all the numbers from 1 to 10, because you're just essentially multiplying the interval by 2. So that's what we're doing. So I'm going to stop using this guy for more generic ones. So I'll just make this 21 again. So I'll make this 21, and here we can actually start from 11, right? So I'll remove this guy over there. We don't need to start from 1. We can actually start from this point, from 2,520. We can actually start from there, right? Can actually start from there because we already know that this divide, we are starting with numbers from 1 to 10, and we're searching for the numbers from 11 to 20. And since that is the case, we can actually change our intervals by that number as well. So we know that the number that is divisible by numbers from 1 to 20 should also be divisible by this number. So if we start there and we're shifting by this number, this should actually be faster. If I run the code again, this should actually run faster than how it ran before. So yeah, and we get the same answer in both cases. So yeah, thanks for watching, guys, and I'll see you in the next video.